Today, I will be the presenter with two co-presenters, and the topic will be the dynamic mapper and the latest updates of it. And we have also a real-life use case, how it has been used. Before we start the session in detail, as always in the knowledge exchange, some things, some housekeeping notes and about our presenters today. So we are the three of us. The first one is Christoph and me, who are mainly the contributor of the dynamic mapper. And we also brought a guest. This is Dominic from WIKA, who is actually, I would say, a user, but also kind of a contributor because he helped us to improve the dynamic mapper and the latest release. As always, some housekeeping notes. Please stay on mute if you don't have any Q&A. Use the chat if you have any question. Meanwhile, we will try to answer them during the session, but also in the end where we have a dedicated Q&A session. This meeting will be recorded, and as this is a public knowledge exchange with also external guests and participants, it will be shared, of course, internally, but also externally, and most probably uploaded to YouTube. And afterwards, I will send around the link so everybody can watch the recording. To the upcoming session of our knowledge exchange, for those of you who never have attended a Cumulocity knowledge exchange, it is actually a kind of an internal format which is used to share knowledge around the company, but we try to extend it for the first time to make it also public for external guests like our customers, partners, people who have an interest in Cumulocity and so on. So we have planned some sessions which are mainly internal, but also maybe external. This needs to be discussed. They are not scheduled yet, but the two topics we want to plan and coordinate are collecting Copilot experience for developers. This is one session we will plan currently. And another one is giving you an update about the latest features of Cumulocity Edge. As soon as this is scheduled and decided if this is an internal only or a public event, it will be announced. So you will get informed about it. As I have said, the knowledge exchange will be recorded. So we will upload it internally to our internal Google Drive folder, and externally we will upload it to our YouTube channel. So it will appear there shortly after this knowledge exchange there, and you can watch it offline if you want to. If you have any topics you want to get covered by such kind of format we're having today, please reach out to ws-knowledge-exchange@cumulocity.com, and we consider your proposal and then plan the session accordingly. Now to today's session about the dynamic mapper. First of all, I will start to give you a rough overview what the dynamic mapper is. Then in a second agenda point, Dominic from WIKA will take over and give a real-life use case and a demo how the dynamic mapper is used at WIKA. And then in the third part of this meeting, Christoph and myself will give a demo about the latest features of the dynamic mapper. And finally, at last, we will have Q&A and a chat about any topics which are open for you. So let's start with the overview. The dynamic mapper is an open source tool that has been developed, I would say, 2 to 3 years ago, with the need to easily map data from any data source, be it devices or third-party systems, to the Cumulocity domain model and Cumulocity API. As you might know, Cumulocity has microservice capabilities where you can implement your microservices. And in the past, it is quite common that you implement, if you have the need to decode data and map it to the Cumulocity data format, You can implement a microservice, deploy it to Cumulocity, and then you can also do the mapping yourself. But we thought, why not making it on a non-coding way? And this is why we came up with a dynamic mapper, which is a low-code or no-code approach of doing such kind of mappings. Yeah? So first of all, it is wizard-based. So we will see that definitely in the demos, that you can easily create a new mapping, and then you define what is the source template, or what is the connector or the system, the source system where you want to get the data from. And then you define a source template, how the data looks like, as an example. Then you select the target template, which is most probably the Cumulocity data format. And here is an example of a measurement, for example. And then you can test it. And then you click finish, then you activate the mapping. And then if data is received to the dynamic mapper, it is automatically mapped in the background to Cumulocity data, and you can work with the data in Cumulocity. That is the approach of the dynamic mapper in a just user interface, no-code approach, and make it very easily also for beginners to actually, which has a need to map data to Cumulocity. Then it has been extended to not only supporting common brokers like MQTT. So this is where we started. We started with using just MQTT, and then we extended it to a multi-broker support that we now can not only support MQTT or the MQTT service, which is part of Cumulocity and will be shortly in a public preview, but also Kafka, HTTP, and any other probably message approached connector that can be connected to the dynamic mapper. And then we also extended the way that it's not only must be JSON that can be processed, but also having multiple data formats and so on. But this is the first phase. And then, of course, once you have created the mapping, we need some kind of management. And this is also part of the dynamic mapper. So once you have defined your mapping in a wizard approach, you can then define if you want to activate the mapping, deactivate the mapping. You can debug a mapping. You can, of course, delete a mapping. You can export it and import it again to another tenant. So all this kind of management capabilities are also part of the dynamic mapper. We also have some basic monitoring implemented that you can see if you have defined a mapping on a data payload, which was just assumed, and then in real time other payload is received. Most probably the mapping will lead into an error, and then you can see in your monitoring that some mappings are failing because of some reasons, and you see that okay, the mapping is failing. It has been also implemented from the beginning in a scalable way that we say, okay, it's implemented for multi-tenant tenants, so you just need to deploy it once in your enterprise tenant, for example, and then you can just subscribe it to your subtenants if you have an enterprise tenant environment. And also because we're talking about a very high throughput component here, which needs to handle a lot of mappings and concurrently, it has been also implemented in a very high asynchronous way, which allows a very high throughput of messages in the end. As I have stated already, this is an open source project. You can get the dynamic mapper here at GitHub on our Cumulocity IoT org. And just today we have released the 5.0 release, which has major improvements in the dynamic mapper, which we showed you will show you in the third part of this knowledge exchange. Let me give you a short overview about the high-level architecture about the dynamic mapper. As I have said, it is meant to integrate data, but also has been extended later to get out data of Cumulocity. This is why we have this kind of two flows here in this slide. So first of all, we have mainly devices which are connected to some kind of message broker in some circumstances. So MQTT, Kafka, as I said, or some device also speak and HTTP or any other message broker data format. message broker format. And then this kind we call connectors in the dynamic mapper approach. So we have a concept developed and an interface where you can define what a connector is, how to connect to this connector, how is the connector considered to be healthy, and so on and so on. So this is all defined in an interface of the dynamic mapper. Then we have so-called payload processors, which can be implemented and extended as well. So we have default payload processors for JSON, protobuf, hexadecimal payloads, and of course you can extend it if you have some custom data format which is not covered by the default processing. Then we have the mappings, as you have seen on the screen, where we can define so-called inbound mappings and outbound mappings. Inbound mappings are mainly to get data in Cumulocity, and outbound mappings means get data out of Cumulocity somewhere else. And in between, we heavily leverages two ways how you can define mappings. First of all, it's a graphical way, but graphical is not always sufficient. Sometimes you also need to provide some basic expressions, I would say. And here we use the expression language called JSON-Nata to do that kind of expressions in the graphical way. And in the latest release, we also have now the option that you can define, I don't want to have a graphical mapping, but a code-based mapping, which is then plain JavaScript, and you can just code JavaScript to do the mapping. And as I said, if you have defined that, the data will be processed, the mappings will be executed, processed, the data is going through Cumulocity. And for the outbound mapping, it's the other way around. We're leveraging the notification 2.0 capabilities of Cumulocity to subscribe to messages from Cumulocity. Then we will do the mapping to a data format we want to have in an external system. Here we currently only support JSON. And here we have connectors like WebHooks you can call, but also, of course, any other of the others connectors, and then publish this message to a third-party system in that way. And this is just a high-level architecture. If you have interest to discover more how this is implemented, again, it's open source. We have a comprehensive documentation, and the sources are open, so you can watch them yourself. And with that, I wanted to hand over to Dominic already to give you an example how the dynamic mapper can be used and how it is being used at WIKA.
Thanks a lot, Stefan. So I just pick up the presentation and will share my screen, how we work with the dynamic mapper. First of all, thanks a lot for this opportunity to join this session here. So hopefully everyone can see my screen. So because I'm not sure if everyone is not aware of who's WIKA, a short word from this side. So WIKA is well known for measuring instruments like pressure, temperature, level, and force technology. So we are more than 11,000 people over the globe and working in more than 75 countries. And have a total turnover of 1.3 billion. So enough about what is WIKA. Let's jump in how we use the dynamic mapper. First of all, we are using the dynamic mapper to decode LP1 messages from our devices. So we have a whole portfolio for the pressure, temperature sensors, which are connected over network management to the Cumulocity. So it's a big block in the middle with the decoding encoding part. So what we saw in the past, we had some challenges to decode these messages of these devices. So we had in the last 1.5 months huge conversation with Christoph and Stefan, and faced out some requirements which we have for this dynamic mapper. So here we saw the challenges that we have several devices with a complex payload which are not able to decode with the device protocols which are provided from the core platform. So here we asked it to have the capability to use the JavaScript support. Why we would like to have this JavaScript support was that from the LoRa 1 Alliance, the decoding is defined as a JavaScript decoding. So nearly every producer of a sensor. So also WIKA is not using only their own sensors, or for example, for environmental sensor or GPS tracking, we're also using third-party products in for our complete holistic solutions. And yeah, over this 6 weeks journey, we established a new feature with the JavaScript support, and for sure that we can decode address with one message multiple endpoints of the API. So how we do that, I will jump into a short demo. I've opened here in our platform a device. It's a PGW. What is a PGW? It's a pressure device, and here they have the challenge that we have a really dynamic payload, which is complex. So we have in several payloads informations like the measurement range, the device information of a cell number, but also measurements like the pressure and the temperature of the device. So first of all, we set up a outbound connection, and I select the webhook, the internal one. Why we do that, I will come later to it. So you can see here in new interface of this guide that we can say we can filter to the inventory, so of the type of the device, which is really capable. So we can define in this way, okay, for the WIKA device, use this mapping, and for other devices, use a different flag, for example, device X. So with this, we have the first filter level. Next of them, we're using as the LoRa agent of the Cumulocity platform. And for that, we have a next filter on the next page that you can see in the bottom. So we are subscribed to the internal events because the mapper is the agent is generating an event in the Cumulocity platform, and we are filtering all of the events of this type because this is the inbound information which we get. So all of the information we get from our network management as an event, it's formatted in this way, and we transfer from the source. You can see here, so in the source, in the information of the uplink request, the data, this hex frame of the data, and all of the information which I sort here are transferred in our template on the right side, like the hardware information, the schema version, and so on. Now we do that. We use the JavaScript functionality. Here in the bottom, you can see the provided decoder, which is really complex, which is provided from our R&D team. So with this approach, we have can really easily map information of this decoder to the required format that we can use all of our own developed widgets in the way which we need it. And so we define here in just this mapping where the informations are stored in our decoder, and format that into new objects of the platform. And next of them, we can directly test it. So you can see here still the input, and now we can directly start the substitution process and get here on the right side the decoded information, like here the configuration channels, the hardware information of the device, the revision, and the serial number. So it's really easy to and really fast to implement new devices. So as Stefan mentioned, we do not need now to develop a new microservice. We can really implement the JavaScript into the this mapper service and can bring that to our required format. So this was a short overview how we can use this mapper in our approach. So I guess now I hand over back to Christoph.
Yeah, I will take over. We will open the microphone for the first question Q&A. So if you have any questions about the use case, you can ask the question now to Dominic. Are there any questions to Dominic and about the use case he showed to you?
Maybe something in the chat.
You just have John asking plans for productizing it. This one I will answer later. If not, we can take you can take your time, and in the end, you can also ask some question and answer the question. Then I will take over again, and let me share the screen quickly. Share. Here you go. Now what we have seen how the dynamic mapper can be used at WIKA. Now I wanted to highlight the latest feature we have implemented, and one of them, or some of them, you have already seen in the use case. But now we want to explain in detail what has been implemented and why we have implemented that and how it has been implemented. So the first thing I wanted to mention is some kind of prototype we worked on together with Kanishk, who is an AI expert at Cumulocity, to help us to make the dynamic mapper also AI enabled, so that you cannot just wizardly based can create your mappings, but also having some kind of chatbot. I would just roll the video here right now, where we have trained the chatbot to ask the people, for example, here, what is the target API you want to the mapping be for, then to provide a source template, which is in JSON here in this example, giving the mapping a name. Then also, what is an example mapping topic? Plus is the wildcard. This is an example. So hello devices stands for the wildcard for plus. And then what is the target fragment we want to map the data to? What is the series or the value of the measurement we want to map the data to? If you want to use the current time of the timestamp or the timestamp, which is a part of the source template. And then in the background, it will generate a new mapping. And then you have a new mapping in the dynamic mapper and can execute it. Of course, this is just a prototype. We just experienced with that. We also thinking about, especially to extend the AI support for the expression language, JSON, that in future that you get some support and suggestions saying, hey, I want to map this complex part of my source template to a measurement on the right, how I can do that. And then it will give you some suggestions of expressions similar to regex, saying, okay, please use this, try this, and test it, and then maybe optimize this expression and so on. So this is also currently planned. So we have some activities around AI also with the dynamic mapper, but this was most likely a side project. Some of the core capabilities or new features we have implemented was the HTTP inbound processing, which opened up the dynamic mapper not only to message brokers, but also to devices which are mainly speaking or implementing and REST on HTTP API. So what has been implemented? First of all, with the latest release, there will be a new default connector, which is called default HTTP connector, which is created automatically and provides an endpoint out of the box, which is then, of course, a dynamic mapping service, which is a microservice of the dynamic mapping service. Then we have the HTTP connector, and then it will accept any messages on any subpath of that message, which is then equally mapped to the topic structure of a message broker. Yeah, I will give you an example shortly. This endpoint is secured by a role that needs to be assigned to a specific user. So not everybody can just publish anything. So you can create a new technical user or device user, and then that device user needs to be assigned to that role. And then, of course, you can publish payload to that data. It also supports wildcards in the URL, so you can also extend device identifiers and so on. Let me quickly give you a demo how this looks like. So first of all, we go to the mapper where it is. Here we are. As I've said, the first step I can skip because the default HTTP connector is already there. It's also enabled. So the second step is that I create an HTTP inbound mapping This one I have already done, so I can show you how this works. So first of all, I select the connector I want it valid for. As you can see, mappings are not designed to just one specific connector. It can be enabled for multiple connectors already. Yeah? So if I now select also MQTT, it means it can handle messages coming from a topic from MQTT, but also from the URL. Then I click on next. Then I give it a name. Then I say, okay, what should be the topic? And here you can see.
One remark: is it possible to raise the font size? It might be a little.
Yeah, okay.
Not all of the other feels the same.
Is it better now?
Yes.
Yeah, okay. Thank you, Christoph. Yeah, I have a very big screen. Then we have the mapping topic and an example topic, which is used for testing in the last step. Yeah, and then I select the target API. So here I receive some messages, and then I want to map it to measurement. I can say if I want to create a device, if a device identifier doesn't exist in Cumulocity, it will be created automatically. If I not activate that, the message will be dropped. It will check if there's a device existing. If not, saying there's no such a device known, so message is dropped. I can also switch that I want to use external ID, meaning that I'm using an external identifier to map the data, not some internal Cumulocity data, source ID and so on. Then I have the target template, which is the temperature, mainly very basic. And I can see also automatically by the mapper, I get the sample payload here, the sample path I have provided. And here I have the target template, which is a typical temperature measurement. As the next step, I can do the substitutions. So first of all, I map the device identifier, which is here part of the path. So I map the first entry or second entry to the external ID. This is the first mapping. The second mapping is I map the temperature to the value, the unit. And here, for example, I used a JSON data function to calculate the current timestamp and not using this timestamp. But of course, can also use this timestamp and map it directly here. But in this example, I just used the timestamp and the message accurate. Then I can test that. And it gives me two messages. First one to create the device if it doesn't exist. And then the second one, how it looks like with the data map. Then I can confirm it, activate that mapping. And then I can go to, simulating the device, saying I want now that the data is sent. For example, here I prepared that already. Let me switch to the right environment. Here we go. And now it states it's okay. And here you can see I'm using HTTP connector, the device. Here's my device identifier, temperature, and this is my payload, and it states it's okay. And if everything goes fine, this is now my device, this Berlin 01, which is the external identifier, which was part of the path. And here you can see the measurement arrived. And now I can just, as I said, I used now I can just send multiple messages to the mapper, and you can see that the data is instantly received by Cumulocity and mapped successfully. So this was the first new feature I wanted to show. Let me switch back to the slides. The second one is actually the other way around. So we are not getting inbound data, but now we enabled the capabilities of getting data out of Cumulocity and send it to some HTTP endpoint of any HTTP endpoint of your choice, which is also called WebHooks. It's a common word here to systems which provide webhooks you can implement to send data to. As I said, here we have another connector which can be defined. It can forward data. It leverages notification 2.0. Again, the context path here is also the topic structure defined in the mapping. We also have a flag which is called Cumulocity internal, but Christoph will explain later what this means in detail. And of course, the mappings is, as I said already, does not need to be changed at all. It can be work for multiple connectors, including WebHooks. So I can also select an MQTT broker to publish data to an MQTT broker, or if I have a webhook connector, then I just post it to a custom endpoint. And again, I want to give you a short demo about it. So first of all, what I need to do is to create a new connector. So I go to the dynamic mapper, select webhook. This is my demo webhook connector. Here you get some basic description. And then I need to use an URL. I'm using a public service which is called endpoints dev, which is used for development to test if some webhooks functionality is working. So here I use the base URL. Of course, you can define some authentication headers, basic bearer tokens or whatever. You can define the headers. And a health endpoint to check if the system is up and running. If it's not up and running, then the connector will be recognized, hey, the system is not there, so we cannot forward the data. So it's actually just a GET request to this endpoint. And here we use a post, or you can also override it with some other methods. So I just click on save, click on enabled, and then the GET endpoint will be requested in the background, checking if the system is there. This might take some time. Oh, it's failed. Let's check again. Oh, it's because I guess why that? It's always like that. Okay. Let's see if I did something wrong here. No, this looks fine. Save again. Try. Now it's connected. Then I go now to an outbound mapping because, as I said, I want to get data out of Cumulocity. And here I also have created already a mapping. So I can go to this mapping. And here I see all the connectors which are available. For outbound mappings, as you can see, we have the MQTT, we have an internal webhook, and we have a newly created webhook connector. I click on next. Then I again select what should be the published topic. Here I choose event, outbound, and the wildcard for the device identifier, the external ID. I can provide a filter. Dominic already showed that. This is the device filter. Yeah, so it's not related to the API I'm using, but the related device. If a device of a specific type should be used to forward this data, only if I keep it blank, all kind of data of the specific target API will be forwarded on a specific filter I define later. Then the top example, this is again this identifier Berlin01. I use the external ID, and here we have an option to extend the content to override the HTTP method, for example. I click on next, and as you can see now the source template is actually the Cumulocity template, the Cumulocity payload, which is in this case is an event. This is a typical event. We have a text, we have time, we have a type, and I have some custom fragment called bus event with a string stop event. Also, we injected some internal mapping information where we can map the source ID or the external ID. And here we have the filter capabilities, which needs to be defined for the outbound mapping and always needs to return result as true. Because here I filter only for events of type CHY bus events. Yeah, so I can also make it content by saying, okay, if the temperature is below or above a value, then only take this message and send it out. So this is the filter. The filter is also true. So I can click on next. The target template is some custom format. It's similar to the event here, but a little bit different. And then I do the mappings actually and saying, okay, the text should be mapped to description. The time should be mapped to time. The type should be mapped to event type. The identifier, so the external ID of the device for that event should be mapped to the third position in the path. And I also map the internal Cumulocity ID to a fragment called device ID in my example. So I click on next, transform test message, checking how this works. And I can see, okay, looks pretty good. Then I click on confirm, activate that mapping. And now I need to trigger creating an event like I have defined. For example, here I have the bus event now with the current timestamp of type stop event for my device. So maybe I missed this step. What I missed is actually I need to create a subscription. Because before I can receive messages, I have created my mapping, but now I also need to define the devices I want to subscribe for Cumulocity on. This is the concept of Cumulocity notification 2.0 service, that you can select a filter of devices you want to subscribe on to receive message on. So I have selected 2 devices here, and this is the one I'm creating now the event for. So I can see them here in the list. I have subscribed to it, and I can manage it. Let's go back to my mapping. And now I trigger this event for the device. So now I have triggered it. And as you can see, here I'm getting already the messages. Let's do this again. And another message is received by my simulated third-party system, which is implementing an endpoint and webhook implemented. Yep, and that's another feature I wanted to show. Let me quickly jump back to the presentation. Here we are. Slideshow. The third one I just want to mention because it's actually an enhancement. We received the requirement that it might be useful to not only create events in Cumulocity, but also attach binaries. In Cumulocity API, this is already implemented, but the dynamic mapper, it wasn't implemented. You can just select the event and then you can just map fragments, but the binary API or attachment API of event wasn't implemented. So this is what we have implemented with the 5.0 release. And it works the following way. When you're creating an event or selecting the event API, there is a flag which is called with binary. If you set that, then you will get an enhanced context in the target template, which looks like this. And here you can define the attachment name, the attachment type, and the data. And then you can map the base 64 string to that. And currently we only support it because this was a requirement of base 64 strings images that should be uploaded. But of course, later on, we also want to improve it, also supporting byte arrays, maybe. This depends. But currently, the only requirements we received was base 64 is sufficient. And in the end, of course, the events will be created in Cumulocity. And because of the type, if the type is right and the name is maintained, you can download the file and you can see it directly in Cumulocity. And with that, I will hand over to Christoph to show you 2 other amazing features we have implemented. You're on mute, Christoph. Still on mute.
So I will share my screen. Thank you very much. So I will continue with sample number 4, which is code-based, shows the code-based mappings in this context. So we listened to some feedback from colleagues or other customers working with the dynamic mapper and realized that in some cases it is cumbersome to work with JSON data. So this is with simple mappings, for example, mapping one field to the other field, or doing some arithmetic calculations, it's quite easy, but as soon as you start in doing some transformation, which I will give an example, it is not straightforward. And if you do it not every day, you will have to invest some time. Another case where we found that the JSON data is not the right way, because a lot of libraries already exist, as we have seen from Dominic. Codecs exist, and customers would like to reuse these libraries. So there's a good way to use these code-based mappings for this. And there are cases where you would like to have a little more control over how your mapping is processed at runtime. We have seen, for example, for inbound mappings, you can define the target API, either alarm event or a measurement. But in some cases, when you have a more generic message and you only realize while you process a message if it is an alarm or an event, or in other cases it's a measurement, because in a specific field there is a numeric value. So there needs to be a little more control on how you can target your message to the right API. So this was only possible by introducing a different form of mappings, which is named as code-based mapping, and it uses JavaScript. JavaScript is a good choice because it can be executed or tested in the browser environment, and it can be interpreted in the microservice to be executed at runtime. In order to get started with samples, we have something that is called code templates. So these are samples that are part of the web UI and help you to get started with a JavaScript API and how to extract your data from your incoming source and map it to your target source. So now I will give you a short sample for this. So for this, I already mentioned that we had some experience from a large retailer in the US, and they were looking into a way to send data from their scales from their grocery stores to Cumulocity. And they came across this message, which you see here. So
maybe Christoph, you need to share the screen again, because
okay.
I have just a frozen screen.
So, yeah.
Yes, and can the Google Meet window on the right side be removed? It's blocking the image.
So,
Yeah, it will, I think.
so can you see my screen again?
Yeah, now we can see it.
Okay, perfect. So I was starting with selecting the inbound mapping, and this was is a message sent from a scale, and this contains some information on the specific device. So this device is identified by the serial number, and in here, these are the business data. So it contains two readings, the cross weight and the tara weight. And these two telemetry readings, they should be converted. They almost look like series in Cumulocity, but only almost. Though that should be converted to series. So on the next step, we see the different mappings as we have seen in the mappings before, but the last one, this one is the most most complicated. So here it means that you transform these two elements, fragments, to some series in Cumulocity. In order to do so, it requires some rather complicated JSON data expression, and that was one reason that is not so intuitive. So that was one reason to look into how to do the same with a code-based mapping. So now to do the same sample with a code-based mapping. So we start by adding a mapping. In this case, we choose JSON as an incoming payload, and we define the substitution not as JSON data, but we want to define the substitution as JavaScript. So now we pick the incoming connector, which will be our MQTT, and in here we give we enter some information on the specific name and repeat the same topic as we have seen in the other one. As the information for the device is coming from the payload and not from the mapping topic, we leave it as it is. So we use an external ID. We create the device if it not already exists, and we continue by specifying here the payload. I take this from the sample that we have seen before. And on the right side, we delete everything that we do not need, because this is an approach that we use in code-based mapping. We build up the message, the target message, completely from bottom up. Now we are ready to go to the next step. So here we define the templates. Now we define the substitutions. And this is where the code templates that I mentioned before come in. So we have defined a couple of code templates that help you to get started with the way how to extract your data here from the incoming payload and then map it here to the respective target fragments. I've prepared the JavaScript code here. It's a snippet that I will copy. And so that is follows the same pattern that we have seen before. So here's our incoming payload, and we extract the specific information. For example, here is the part where we look into the source, into the payload, into manufacturer serial number, and we add this information as a device identifier. So we know for which scale this measurement should be assigned to. Then we continue with next and test everything. So here we see that we have these two series here, cross weight and tar weight, and here on the left side or on the bottom side, you see all your outputs, which you can write in your JavaScript code, and it will be reported here. Now we are ready to test our mapping. This is our new mapping. We enable this. And now we take a look at our scale. This is the scale that was already registered, and this is identified by this external ID. Now we take a look at the mappings. Just a minute. And as we defined as an incoming connector, we defined a broker. So I'm here connected to this broker, and here is my sample message. This one is the same external ID that I use to identify my device, and these are my two measurements that I would like to ingest or send to Cumulocity and transform. So now I start this, and the message, and here you have seen that something comes up. Let's repeat this. So we get a nice line. And here you see that the messages that we sent before are received and mapped by the respective mapping that I have defined before. So that was my first sample, and if there are no more questions for this, I will continue. Okay, so last sample is about filtering, and filtering is a concept that we have seen before. So we have seen it in the outbound mapping, because this is a way to link your mapping to some data that is coming through the notification 2.0 API. So we do not want to activate every mapping. We want to link a mapping to specific content. And in this case, you can define a filter on an inventory. So that is type 1 filtering that you can do. So I would call it more a context-based filtering so you filter on the context of the data that is coming in, if this mapping should be applied. Then there is a second type of filter, which is more a content-based filtering, which you see here. This is filtering out all the temperatures that are below 50 degrees because they are not relevant to us, and we only want to see the measurements that are above 50 degrees. And this is a simple example, but you can define rather complicated JSON data expression using functions or even Boolean expressions to filter on the content in this case. So now I turn back to the sample section and turn to an outbound mapping. In this case, we have a measurement. So here I have defined the webhook. A variant of this we have seen before by Stefan, and this was really an external system. In this case, we use a special form of a webhook, and this is called an internal webhook. And here we have set Cumulocity internal. And in this case, what happens is we receive the notification or an event or an alarm or a measurement through the notification 2.0 API, and then we use a mapping and then send it back to Cumulocity using one of the REST APIs. So that's what we signify here by checking this this box. Now I go back to my outbound mapping. Here is my outbound mapping. I have selected here the internal webhook, and here I've chosen that the transformed message is sent to measurement. I'm using here a filter, an inventory filter as well, and I'm using the message context as well. So here you see, for example, for the message context, that was part of Dominic's sample as well. So you can define you can override the method here as well. You can, this time we use a post method, but you can use a patch method or a delete method or any other method as well. And here's our content-based filter. So we are only interested in seeing temperatures that are above 10 degrees. And this is part of our payload, which we see here. Now I continue, and this is a code-based mapping. So here we have our source object. We extract from this fragment, we extract the value and multiply it by 2. And then we transform it and set it up as this fragment here, as the temperature process. So what I will do in the demo in a short while is I will send a temperature measurement to my device and will take a look at if immediately I get a temperature processed with a double value from the input. Okay, let's continue. Here I can test again. So these are my inputs that I see here at the moment. And here I'm ready to enable my measurement. It has been enabled. Now I go to this device, and in the background I will generate a new measurement. In the first case, I will just send a measurement with 5. So with 5 degree, here's my measurement. I will send another one with 25, and that should appear then down here as well as a process. I turn this one here, and as you see, here is my 50 degree, and this one was my 25. Let's do another one, 35, and then we are ready for the Q&A section. Okay, so here's my 30, my 50. So just a second, I think I have to refresh for the graph to scale. Oh, yeah. Here's my 60, and here's my 35. And that concludes my demo for the outbound mapping using filtering and doing some processing with the messages that I received. Thank you very much for your attention, and I think, Stefan, we are ready for some Q&A.
Yes. So this is basically what we wanted to demonstrate. If you have any questions, I already tried to answer the questions in the chat already. But if you have any other questions, please open your microphones and speak up. Any other question? But maybe we can also talk about the question Tristan has. Tristan has the question, actually 2 questions. First one was, the question is, are there any plans to productize the dynamic mapper? Yes, we are currently in discussion with product management and also R&D, how we can leverage what we have on experience to also make it into the product. It's not yet clear if it's make it in the way of the dynamic mapper to the product, or it will be a third-party component or another component. That's currently in discussion. But what is there? It's currently the dynamic mapper is an open source component. The question about the multi-tenancy, yes, this has been built from the beginning. So the full microservice is multi-tenant enabled, as I said at the beginning. The JavaScript code-based mapping, this was another part Tristan asked about. How do we prevent to execute some, bad code or harm code in the JavaScript? And I answered that, but maybe you can jump in, Christoph, that we only expose specific interfaces which we have whitelisted and defined in the microservice, which can be used in the JavaScript mappings. So you cannot execute anything else.
Yes, that's the case. So that's something. So internally we use Graals.js, and there is a way to restrict this, as Stefan mentioned. So you can whitelist the methods and classes that you want to expose, and very fine-grained give access to JavaScript.
Yeah, and this is what we leverage. Then there's Florian. Florian, you have a question.
Yeah. So thanks, first of all, a really good presentation like that. Maybe one question to Dominic. Can you tell us a bit more about how WIKA define the requirement? Can you tell us something about the use cases or how you think your customers will use Dynamic Mapper? Who will use it?
Sure. How we define this? So as WIKA, we are providing turnkey solution to our customers through complex solutions. And here we saw in the past the challenge that for third-party products, we had to implement on a short notice. The challenge was really to build first of all a full microservice with all of builders, and then we have to most of the time there's a JS script provided by the customer, but we are currently using most of the time C# microservice services, so we have to transfer the code from JavaScript to C#, and all of this efforts can be terminated with this mapper because we can directly implement it, just set up our data models, map that, and it's a more faster and also efficient way instead of putting the whole developments into it.
It improves your life, but not the life of your customers, but which is good as well. Sure.
Right.
Yeah. Okay. Thank you.
Welcome.
Jan Humble, you also have a question.
Yeah, thank you very much for this. I have tons of questions, but I'll try to boil it down to 2 or 3 only.
Okay.
So in lieu of this being productized and having kind of a proper setup internally within the framework, have you guys done any benchmarking in terms of what it requires to run it, what kind of throughput we can achieve with this? But more importantly, if we're going to include it, for example, in an offering, the microservice sizing that we need to do to be able to accommodate it under different loads, for example. Do we have any guidelines around that?
Yeah, I can answer that. We did for some opportunities, we did some kind of benchmarks. We also did some, I would say, synthetic benchmarks, but not on a real use case. But we had actually a real use case where we did some tests, and we tested with around, I think, max to 1,000 TPS, or even less, or even more, Christoph. It was 1 to 2,000 TPS we tested to get through as a throughput. And it was, I think, we used for that configuration 4 GB of RAMs and 4 cores.
Mm-hmm.
The initial setup for the microservice is, I think, 2 GB of RAM, because
and half a CPU.
And half a CPU, which is not much, But even with that default configuration, it is sufficient to process a lot of messages already.
Okay. I mean, it would be useful to have some sort of table that we can look into. For example, if we need to right size it on the bill of materials that we need to put together, that'll be good to have. And then my other question is, in terms of one of the things we've been asked for is for the customer's customer to be able to self-service themselves. In terms of, for example, if you give them inventory roles, they would only be able to do the mapping to their own inventory. Is that something being considered as a feature as well?
Not sure if I got the question.
So you saw that you could map, you could select the devices to the mapping from, right, as your sources.
Yeah.
And some of the things, but you would only be able to select the devices that are part of your inventory role entitlement.
Okay. The role things. Okay. This is currently not yet implemented, I guess. We need
feature request for the future, maybe.
Yeah, feature request for the future.
Yeah. No problem. And then my final question. My final question is: any plans of including XML as well in the mapping there as well?
I mean, this is something depends on the requirements. I mean, this is, for example, the components that you have seen works with JSON very fine. So it needs some adaptation, but for sure it's possible. So
I understand. I understand. The more demand, the more you will consider it as well. But I think it's the problem. The reason I'm asking is because things like MT Connect on some of the industrial equipment work with XML, and just wondering if that's
we have not looked into XML, but the concept and the framework is so when I opened the stepper, so you choose your format, and that is a natural extension point. There's a natural extension point to use a different format. So it's not it's doable, and it doesn't require any changes. So it's a natural extension. Yeah.
All right, thank you very much. Yeah.
It's just a payload, an additional payload processor.
Yeah.
And
for example, we have hexadecimal or comma separated files as well. So that's only a variation from some basic processors that we already implemented.
Yeah. So if you have that request, can just approach us and we can.
I'm not sure it's critical yet. I'm just wondering if it was down coming in or something. Yeah.
I mean, the past requirements, as Dominic mentioned. So we have been working in the last 1.5 months on it. So we did the basic design and first release of the code base, and then came the fine requirements and the from Dominic, and we worked in iteration. So that's a natural way of working that we have been working over the last 1.5 years to include little additional features. And so the architecture in the microservice as well as in the UI, they have matured to cope with changes. So for example, to take out the JSON-based mapping and insert the JavaScript-based mapping. So that would be a similar step for XML-based. So you would require a different editor, and so that would be possible.
But you don't need to rewrite the whole thing.
No.
Yeah. Okay, we're already over time. Thank you very much, especially to you, Dominic, for attending and giving your insights into how WIKA is using that. If there are any follow-up questions, please do not hesitate to approach us internally or using the tech community, or just send us an email. Thank you very much, guys, for attending, and see you in one of the next knowledge exchanges.